At 1.4 billion kilometers from Earth lies a moon that has intrigued scientists for decades. Titan, the largest of Saturn's moons. It is covered by a thick orange layer of clouds that completely block the view of its surface. For a long time, no one knew what was down there, whether it was rock, ice, or something entirely different. All we had were theories and blurry images. That changed in 1979, when the Pioneer 11 probe passed through the Saturn system and detected something unexpected. Titan had a dense atmosphere, composed mainly of nitrogen, the same gas that dominates the air on Earth. Mixed with it were traces of methane and hydrocarbons, substances made of carbon and hydrogen, essential to the formation of organic compounds. This discovery was astonishing, because until then, scientists believed no moon in the solar system could sustain such a complex atmosphere. Titan revealed itself as something unique. A world with climate, active chemistry, and hints of processes similar to those that once shaped primitive Earth. But there was still a problem. No one could see the ground. Titan's clouds were so thick that even the most powerful telescopes could not pierce them. What happened beneath that orange shroud remained a total mystery. For years, science was trapped in speculation. Was it a frozen world of solid ice? Or could hidden oceans exist below? What once seemed like a simple moon became one of the most promising places to understand how life might arise in other worlds. Even after Pioneer 11's discovery, Titan remained shrouded in mystery. The images were blurry, and scientists could only speculate about what lay beneath. For 25 years, the surface stayed hidden, until 2004, when the Cassini-Huygens mission reached Saturn's system. A collaboration between NASA, the European Space Agency, and the Italian Space Agency, Cassini was designed to study Saturn and its moons with unprecedented precision. On board, it carried the Huygens probe, built to land on Titan itself. For the first time, radar and infrared sensors managed to pierce the thick orange haze. The images revealed a stunning world. Vast plains, deep valleys, and winding channels carved into the surface. Everything pointed to the presence of liquid activity, but not water. On Titan, water is frozen as hard as rock. The flowing substance was methane and ethane in liquid form, creating rivers and lakes that resembled Earth's landscapes. This was a historic breakthrough. Humanity had found, for the first time, a world beyond Earth with stable liquids on its surface and an active climate cycle. There were rains, evaporation, and clouds, but made of different materials. Titan was no longer a simple moon. It had become a natural laboratory for studying how complex worlds are born. And from that moment, every new discovery from Cassini brought more questions than answers. In January 2005, the most daring phase of the Cassini-Huygens mission began. The European-built probe separated from the main spacecraft and started a descent of more than 2 hours through Titan's thick atmosphere. As it fell through the orange haze, its instruments recorded data never before obtained from another world. The air pressure was higher than Earth's, and constant winds swept across the alien sky. As the surface drew closer, the images revealed mountains, valleys, and a network of channels converging into a dark plain. Scientists believed it was a shoreline, perhaps a methane lake. But when Huygens finally landed, what it found was different. The probe touched down with a soft impact, sinking about 12 centimeters before sliding a short distance and coming to rest. Its cameras revealed a surface scattered with rounded stones and smaller pebbles across a sand-like terrain. It looked like the dry bed of an ancient river. Those rocks were blocks of water ice, hardened by the intense cold. The ground, though solid, seemed moist, a frozen mud made of hydrocarbon slush. Even without finding liquid at that moment, Huygens revealed a geologically active landscape, shaped by methane rain and erosion. It was the first time humanity had ever seen, with its own eyes, the surface of a world orbiting another planet. The images sent by Huygens confirmed what had only been theory. Titan has an active climate system. There, water's role is taken by methane, behaving exactly as water does on Earth. It evaporates, forms thick clouds, and falls as rain. But this process happens extremely slowly because the sun, over 1 billion kilometers away, barely warms the surface. Titan receives just 1,000th of the sunlight that reaches Earth, meaning its seasons last for years and its rains are rare but powerful. For long periods, the climate remains dry and silent. Liquid methane gathers mainly in the polar regions, forming stable lakes and seas. Then, occasionally, massive storms sweep across the hemisphere, releasing torrents of rain that carve valleys and channels. It's a cycle of centuries, long eras of stillness interrupted by brief ages of flooding. This climate dynamic explains what Huygens found: a dried-out riverbed molded by ancient flows. Titan is not a frozen, lifeless world, but a planet-like body with a complete meteorological system: rainfall, erosion, and evaporation, all driven not by water, but by hydrocarbons. To this day, it remains the only place besides Earth known to have stable surface liquids. Over time, Cassini's observations confirmed that rainfall and methane flows were indeed shaping Titan's landscape. The probe's cameras began detecting bright reflections near the poles, evidence of large liquid bodies. Analysis showed these reflections came from lakes and seas of methane and ethane, clustered mainly around the northern hemisphere. One of them stood out: Kraken Mare, a massive sea spanning more than 400,000 square kilometers, nearly the size of the Black Sea. Its waves rise only a few millimeters, and the surface is so calm it looks like glass. Nearby, smaller lakes like Ontario Lacus mirror the shapes of Earth's lakes, reinforcing Titan's strange geological resemblance to our planet. These discoveries completely changed our understanding of icy worlds. For the first time, scientists observed a full liquid cycle beyond Earth: evaporation, condensation, and precipitation. Powered not by water, but by hydrocarbons. And in Titan's extreme cold, those liquids don't evaporate easily, keeping the surface stable for centuries. Titan became one of the most promising places to search for microscopic life. Combining a dense atmosphere, organic chemistry, and geological activity. It was the first real hint that life might exist under conditions completely different from those on Earth. With all these discoveries, Titan ceased to be just a distant moon and became the focus of modern space exploration. NASA realized that this world contained more than ice and methane. It held clues about the origins of life itself. That's how the Dragonfly mission was born, an ambitious and unprecedented project. For the first time, a probe will not only land on Titan, but also fly over it. Unlike any previous mission, Dragonfly will be a nuclear-powered drone, capable of traveling long distances through the dense atmosphere and landing in multiple locations. It will carry a complete onboard laboratory designed to analyze soil samples and search for complex organic compounds. Launch is scheduled for 2028, and arrival on Titan is expected around 2034. Over 2 years, Dragonfly will explore dunes, craters, and frozen methane plains, capturing high-definition images and studying the surface chemistry. Its main goal is to answer one of humanity's oldest questions: how does life begin? If Titan truly shows signs of biological processes, it could mean that life is not a cosmic rarity, but a natural consequence of the universe. A small helicopter, billions of kilometers from Earth, may hold the key to understanding our own origins. Today, when we look at Titan, we don't just see a moon orbiting Saturn. We see a distant mirror of the primitive Earth, frozen in time. A world with atmosphere, rain, seas, and mountains, where the ingredients of life seem to be rehearsing the same steps that once gave rise to us. Every discovery there changes our understanding of what it means to exist. Cassini showed us the stage, Huygens touched the ground, and Dragonfly will be our first attempt to walk upon it with intelligence and purpose. The journey to Titan is more than a scientific pursuit. It's a reminder that curiosity is humanity's most powerful force. Where there is mystery, there is movement. And where there is movement, there is life. Perhaps, somewhere beneath those orange clouds, simple molecules are coming together, silently repeating the same process that began here billions of years ago. Titan continues to orbit Saturn, wrapped in haze and silence. But now, we see it differently. Not as a distant point in space, but as a reminder that the universe may be alive in more places than we can imagine. And perhaps Titan's greatest secret is not what hides beneath its clouds, but what it reveals about ourselves.